morning, dear students. In the last lecture, we have studied about what are the scalar and vector quantities, what is the position and displacement vector, how to add, subtract, multiply the vectors, and also you know that scalar quantities can be multiplied as in general like algebra only, but there are set of rules for the addition, subtraction, and multiplication of vectors. Also, we have studied about the graphical method of addition and subtraction of the vectors. Now, we are going to study the analytical method, or you can say first of all we will resolve the vectors. What is the resolution of the vector? So, we will cover topic number 4.5. That is the resolution of vectors. That how to resolve the vectors. Now first of all, you consider two vectors, that is A and B. Say for example there is vector A and vector B. Now we will draw the parallel to vector A and vector B. So for example you say this is the parallel of vector A and vector B. And we will get one resultant vector capital A. So what will be this A? This A will be equal to A plus B. What will be the vector A? Vector A will be equal to vector A plus vector B. Now consider that we multiply this vector A with any real number, say lambda. Now we multiply this vector B with another real number, say mu. This symbol is known as mu. So when we multiply this vector with a real number, then we will get A will be equal to lambda A plus mu B. You have also studied that when we multiply any vector A with lambda and we want its magnitude, then it will be lambda into mod A. Okay, so here when we draw parallel to this A and multiplying it with a real number and we got this, you have studied it already in the graphical method, that when we need one resultant vector, so from that direction or from that line, the tail part will be written first plus the head part will be written next to it in addition. So from graphical method we know that A equal to A plus B. If we change the direction of A and B, say this is the direction of A and this is the direction of B, then the resultant vector A will be equal to B plus A. And for this we have studied that in graphical method that these vectors follow the commutative and associative law. So A equal to A plus B or B plus A. The only tail and head part will change. Okay. So this is its resolution. Now we need to understand is a unit vector. A unit vector is a vector with unit magnitude and points in particular direction. So this unit vector along xy plane or rectangular plane, then we have unit vectors, that is I, j and k equal to 1, as it is the unit vector. Now how we will just show this I, j and k while writing. In your book it is given in bold letters, but in writing practice it is not possible to write it in bold letters. So here we need to write one cap. This type of cap is put on I, j and k vectors. So this cap will be available I, j and k. These unit vectors are always perpendicular to each other. This unit vector does not have any unit or dimensional formula. Now, consider that if we multiply, say for example, n is a unit vector. As it is a unit vector, I am not writing it in bold, so I will put one cap on it as it is the vector. So this unit vector, when we multiply a vector with any scalar quantity or any real number, then the result which we will get will be always vector quantity. So if we multiply one unit vector with, say, real number lambda, then we will have this lambda as the vector quantity. So if you have multiplied scalar quantity with vector quantity, then the result will always be the vector quantity. Clear? So now we will have the coordinates, that where is the component I, j and k in the 2 plane or 3 plane, right? So say this is your coordinates, x-axis, y-axis and z-axis. We will always take I along the x-axis, j along the y-axis and k along the z-axis. Clear? Now, say we will take one example from this. We have a vector A. So its x and y components, that is, for example, say A1 and A2. A1 and A2 are the vectors, that is component of vector A. Now, how it is written? This is along x-axis. So we will write it as AXI. A1 will be equal to AXI. Same way, this is along y-axis. Along y-axis, A2 will be equal to AY. And in y-axis, which component is there? J. So what is A? A will be equal to AXI plus AYJ. Clear? Now, you can also write what is AX. AX is equal to A cos theta. What is AY? AY equal to A sin theta. So, along x-axis we take cos theta, along y-axis we take sin theta. So, this is A component. If it is making angle with this as theta, theta shows its direction in this much angle. So, as A makes an angle theta with x-axis, so we will write it here A cos theta and here it is A sin theta. Clear? So here, if it makes the angle theta with y-axis, then we have to write here A cos theta and here A sin theta. So what do I mean to say is, any vector makes angle with one of the coordinates, and we have to take cos theta with which coordinate it makes the theta. Here we have written that it makes theta with x coordinate, so we will take it as cos theta. Clear? So here ax equal to A cos theta and ay equal to A sin theta. According to this, so from here you can say ax square plus ay square. What will be ax square? ax square will be equal to a square cos square theta plus what is ay? A sin theta, a square sin square theta. Now take a square common, so we will get sin square theta, or if you don't understand this, what is this? Cos square theta plus sin square theta. Now cos square theta plus sin square theta, or you can also write sin square theta plus cos square theta. Clear? 2 plus 1 or 1 plus 2, both are the same thing. Same way, cos square theta plus sin square theta, or sin square theta plus cos square theta. So this ax square plus ay square will be equal to a square into, you have studied trigonometry, right? It might be not favorite or not good for you, right? But some of the people might not be liking this trigonometry, but for this sake you have to study in physics, right? So what is sin square theta plus cos square theta? 1. This is the identity. So sin square theta plus cos square theta is 1. So what we got? A square equal to ax square plus ay square. Now what is A? A equal to ax square plus ay square. So this we got the resultant vector A will be equal to root of x square plus ay square. Now same way we can find the theta. So this vector can be this components of the vector can be negative, positive or 0 according to its angle theta. So here tan theta will be equal to ay by ax. Got it? No? So here look. Divide this both ay and ax. Ay upon ax. What is the value of ay? Ay is equal to a sin theta divided by what is ax? A cos theta. A cancel. So ay by ax equal to, now again identity of trigonometry. What is sin theta by cos theta? Sin by cos equal to tan theta. So this is tan theta. So theta will be equal to, if we want only theta, then we will send this tan in next side. So this tan will become tan inverse. Clear? Into का term कहाँ जाता है? Divide में जाता है. For example, you can say tan 2 into 3 equal to a. Now if you send this to that side, so it will be equal to 3 equal to a by 2. If you want to write this 2 in numerator, then it should be the inverse, that is power of 2 is 1. Here it will become power of 2 minus 1. So same case is here. Tan theta, if we want only theta, then theta equal to tan inverse ay by ax. So this is your theta. So from this resolution, you got the resultant vector, which we have already studied in graphical method. Already it follows the commutative and associative law. It's true for that. And here we got resultant vector A equal to root of the square of addition of the different component, that is ax square plus ay square. If it is in 3 dimension, then it might be az square also, right? But we are here talking about the xy plane, right? So tan theta will be equal to ay by ax and theta will be equal to ay by tan inverse ay by ax. So this was topic number 4.5, that is the resolution. Now we come to topic number 4.6, that is vector addition through analytical method. We have seen graphical method of vector addition. It is very nice to visualize the vectors, but in some time it is very tedious to analyze it, and sometimes it does not give that much accuracy. So we will use the analytical method with which we will add the components. So consider A equal to AXI plus AYJ plus AZK. Here we have talked about 3 components, right? You can also take only 2 components also. We will take first 2 components. So A equal to AXI plus AYJ. Same way, B equal to BXI plus BYJ. Now, if the resultant vector is R equal to A plus B, then what we will write? R will be equal to AXI plus AYJ plus BXI plus BYJ. Now, do one thing. Take I component common. So what we will have? I common. What we will have? AX plus BX. Plus, from this 2, take J component common. What we will have? AY plus BY. So resultant vector R will be equal to, we will name this as Rx. Resultant vector R equal to Rxi plus Ryj, where Rx equal to Ax plus Bx and Ry equal to Ay plus By. So we got 2 components I and J, and here Ax plus Bx and Ay plus By, X component and Y component. So R will be equal to, resultant vector will be equal to Rxi plus Ryj. Now we can extend this whole through 3 components. So we will take 3 components. Say for example, consider it in 3 dimension, that is AZK and BZK. So we will have resultant vector R will be equal to AXI, or else you can say A plus B, and it will be equal to AX plus BX plus AX plus BXI plus AY plus BYJ plus AZ plus BZK. Clear? So here it will be Rxi plus Ryj plus Rzk. So this is your resultant vector. Clear? So further, we can also have subtraction also, or the combination of addition and subtraction. You can take T equal to A plus B minus C, and if A might be equal to AXI plus AYJ plus AZK, B equal to BXI plus BYJ plus BZK. Same way, C equal to CXI plus CYJ plus CZK, having 3-dimensional components of A, B and C. So this can be in this form also, or here Tx equal to, we have T, A plus B minus C. Here there is combination of addition and subtraction of vectors. So Tx will be equal to Axi plus Bxi plus minus Cxi. Ty equal to Ayj plus Byj minus Cyk. Tz equal to Azi plus Bzj minus Czk. So these are the three components of t, that is a plus b minus c. So this is the method, that is analytical method for vector addition, and also it is true in subtraction also. Now topic number 4.7, that is motion in a plane. We will consider two-dimensional plane having components xi and yj with a point P and the position vector r. Clear? So this is the position vector r, xi component and yj component. Now from here we are going to study about the position and displacement. So if this point is P having the position vector r, this is your origin, xi and yj are the two components. Now if we consider this point P moves to this point P dash, so the position vector for P will be equal to r and for P dash will be equal to, for example, say r dash. So here we have x and y component. So first the value was y. Next the value was, say for example, y dash. Same way for P on the x-axis it was x, and at y-axis again for P dash on x-axis it is x dash. So this is your displacement delta y, change in the y-axis. Here it is displacement, that is delta x along x-axis. Clear? Getting? This was the position P in position vector, that is r. Now the body travels from P to P dash. So this is r dash. So here we come to know about the position vectors and position and its displacement. So here the position vector was xi plus yj. Position vector was xi plus yj. Now there is the displacement along x and y axis. So for this delta x equal to x dash minus x and delta y equal to y dash minus y. Clear? So change in the position, right? Change in position will be equal to delta xi plus delta yj. So this is your displacement along x and y axis. Clear? So this was the position and displacement. So here these two, position or at x-axis and y-axis, its displacement, and the position delta r, that is the vector quantity. Now we will talk about the velocity for the motion in a plane. Now consider, what is velocity first of all? Velocity is the displacement upon time. So velocity v equal to displacement upon time. So here what was the displacement? Delta r. What is the change in time? Delta t. Clear? Because if any object or the particle changes its position, so there is the difference in the time also. If I am standing here at time t and when I move from this position to next position, so there is the difference of time when I was there and I came here, so that there is some small amount of time difference. So that's why displacement upon time, that is delta r by delta t. So we know that what was delta r? Delta r was delta xi plus delta yj upon delta t. Now this is one property. When there is single term in the denominator, then we can send it to both. So here average v will be equal to, for average we will just put one bar on any quantity. So v equal to delta xi by delta t plus delta yj upon delta t. So change in position along x-axis per unit time can be written as vxi. Change in position along y-axis or the j component, that is vyj. Clear? So this is your average velocity. Now we will talk about the instantaneous velocity. What is the instantaneous velocity? So instantaneous velocity is the limiting value of the average velocity. So we have average velocity v equal to delta r by delta t. So the instantaneous velocity v will be equal to limit delta t tends to 0. Limiting factor of this average velocity. What limit? Delta t tends to 0, delta r by delta t. So the instantaneous value v will be equal to dr by dt. Sharat sir has covered this derivation in his lecture. So you may, if you don't understand this dr by dt, you can go through that lecture. So v equal to dr by dt, that is the derivation of r with respect to time t. Clear? So this was the velocity. Now we will move to the acceleration. What is acceleration? Acceleration, you know from 9th standard that acceleration is the velocity per unit time. So acceleration is denoted by a, that is velocity per unit time. So here what was the velocity? dr by dt. So a equal to, if we want the change, that is delta v by delta t. So a equal to dr by, or else you can say delta r by delta t into delta t. So if we want the instantaneous acceleration will be equal to, here you can write instantaneous a equal to limit delta t tends to 0 dv by dt. What you can write? dv by dt. So here a will be equal to dv by dt. Now understand this. There is derivative, that is first order or in second order. So dr by dt is the first order. If there is square, then it will be d square. Here consider d by dt. Now what is v? V was dr by dt. So we will write dr by dt. So here what you see? 2 times d. So a will be equal to d square r by, this dt, whole dt is twice. So dt square. So a can also be written as d square r by dt square or dv by dt. Clear? So here in textbook there are different diagrams or graphs have been given from figure 4.12, 4.13, 4.14 and 4.15. In that they have explained the position, displacement, velocity, direction, acceleration. Velocity and acceleration have the angle between them in between 0 to 180 degree. The direction of velocity and acceleration can be in the straight line but in opposite directions. So as the direction of velocity changes, the direction of acceleration also changes. So here, for simplicity, you might be solving the numericals. For that, you know there is displacement, say delta r. Clear? So if any body displaces from one position to another position, then and only then there is velocity, there comes acceleration. If I am standing here still in the position of rest, then there will not be any velocity, there will not be any displacement, there will not be any acceleration. So if one body changes its position from one place to another place, then and only then there will be the question of displacement, velocity, what is acceleration, etc. So if there is displacement, say delta r, it can be delta x, delta y. Here in both the plane we have taken delta r. So displacement. Now motion in a plane with constant acceleration. Now consider the acceleration is constant. The initial velocity v0, final velocity v at time 0, t equal to 0 and t equal to t. So here in initial velocity v0, final velocity v. At the time of initial velocity, when time t0 equal to 0 and time t equal to t. So constant acceleration A will be equal to v minus v0 upon t minus t0. So here it will be equal to v minus v0 upon t0. At initial time t was 0. So t. So A equal to v minus v0 upon t. So at equal to v minus v0. This minus v0 comes this side. So v will be equal to v0 plus at. Getting? That if we take v minus v0 upon t equal to a, then cross multiply v minus v0 equal to at. Now this minus v0 goes to the other side of equals to, तो v equal to v0 plus at. जब भी कोई term equal to के उस साइड जाता है तब उसका sign change होता है. Here minus v0 becomes plus v0. So this was the formula. So now if we take the components, for example Vx will be equal to V0x plus AXT. Now if we take along y component, so Vy will be equal to V0y plus AYT. Also if we want to know the theta, then tan theta will be equal to Vy by Vx and theta will be equal to tan inverse Vy by Vx. Clear? Same as we have studied earlier. Clear? Now consider the motion in a plane in two dimension can be considered separately. The motion in one dimension having the perpendicular direction. Now we consider the initial position r0 and another final position r, velocity v and acceleration a, and we will have the formula r will be equal to r0 plus v0t plus half at square. It can also be considered in x and y for the displacement. So along x, the displacement x will be equal to x0 plus v0xt plus half axt square. And for y, it can be y0 plus v0yt plus half ayt square. Now we will come to next topic, that is topic number 4.9. So in topic number 4. Next topic, that is 4.9, the relative velocity in two dimension. Now consider two particles A and B having the velocity VA and VB. Now we consider the particle A in a motion, the velocity of particle A relative to B. So VAB will be equal to VA minus VB. Now consider the velocity of particle B relative to A. So that will be equal to VBA, that is equal to VB minus VA. So from here you come to know that VAB equal to minus VBA. But if we take the magnitude of the relative velocities, then it will be equal. The magnitude of VAB will be equal to magnitude of VBA.